So is this presentation visible to all of you? So right now I have not written anything on this. So I
Yes,
think
sir.
that slide is
Yes,
visible.
sir.
So let us go ahead. Let us try to understand like what is kinematic of machines, right? Okay. So if you observe here, this topic, it is basically composed of two words. So first is kinematics, right? And the second word is machines. So can anyone like describe define like what is basically meant by kinematics? Can anyone tell me this thing?
Motion, movement.
Okay. So motion. Anything else? So anybody else?
And without knowing its cause, like force and all.
Okay. So basically the kinematics is
Study of motion without knowing its cause.
study of motion without considering the forces that produce it. So basically in kinematics, we are going to study the motion of different objects, but what we do, we neglect the forces, right? So definitely if a body is moving, there must be some force which is going to act on it, right? That is going to cause the motion of that object. But here in kinematics, we deal only with the study of motion. We ignore the forces that are going to produce that motion, right? So basically in kinematics we talk of position. Very important thing I am going to mention. So in kinematics, we talk of position, or you can say displacement. Then we talk of velocity, and then we talk of acceleration. So throughout the entire course, wherever I will be talking about mechanics, so basically we are going to discuss these three parameters. So these three variables, they are very important when we are going to study the subject kinematics of machine. So first is displacement, then velocity, then acceleration. Now let us come to the second word, right? Machines. So can anyone define what is a machine? Anybody? So in very simple words, how are you going to define
A
a machine?
tool with a tool which performs some work.
Right, good. So any other definition? Anybody else?
Mechanical one.
Yeah, that is fine. So this definition is correct, but just I want to hear from other students as well. So anybody else like who can define what is a machine?
Sir,
So
any object that reduces human efforts and saves
fine.
time.
Good, good. So basically, if you go in very simple words, or let's say like if you go from the thermodynamics or physics point of view, right? Then you can very easily define that a machine is a device that is going to produce some useful work, and as well you can like say this as well, that it is going to reduce the human effort, right? So, but when we talk of this thing, right, kinematics of machine, so we refine this definition further, right? We make it more precise, right? So now the useful work part is always there, but let me define that. If we are talking of this subject, then what will be the definition of a machine? So basically we can talk that a machine is a combination of rigid bodies connected in such a manner that they possess definite relative motions, right, with respect to each other, and finally deliver some useful work. Fine. So this is the definition of a machine, right? So what I said, that what is a machine? It is basically a combination of rigid bodies, right? So if you see any mechanical device, you will observe that mechanical device is basically a combination of several elements, right? So these elements are generally considered as rigid bodies. So it is a combination of rigid bodies, right? And these bodies, they are going to be connected or arranged in such a way that if you, let's say, like if you disturb one of the rigid body, it will produce a definite motion for the other rigid body, right? That means, let's say, like if you are turning a rigid body through a certain angle, let's say 30-degree, so this rigid body, it is going to transfer that motion to the another rigid body which is connected to it. So let's say, like if it is moving through 30-degree, so the other rigid body, it will be moving in a predetermined way. So let us say it is going to move through 60-degree. So this is like there will be a fixed relationship, motion relationship between two rigid bodies which are going to be connected in a machine, right? So let's say it is going to move 30 degrees, so it is predetermined, or it is definite that the other rigid body which is connected to it, it is going to move through 60-degree. So there is a direct relationship between the motion of rigid bodies. So this is one part. And the another part is always there, that okay, these connections, they should be able to transfer some useful work as well, right? So this is the basic definition of a machine. Now let us try to figure out now what is a mechanism. So one is machine, there is mechanism. So here we are going to separate these two definitions, so machine and a mechanism. So can anyone guess what is a mechanism? So here I have written this definition, right, of machine. Combination of rigid bodies connected in such a way that they possess.
The study of the relative motion of
No.
the individual rigid bodies would be
Good,
mechanism.
good. So basically, if I need to define a mechanism, so how can I define it? So see, the definition of mechanism is already there. So if you need to define a mechanism, you need to remove only this part, that is deliver some useful work. So if you remove this part from the definition of machine, so that is going to be the definition of a mechanism. So if you talk about the basic difference between a machine and a mechanism, so basically here you can write down that mechanism is a, right, combination of rigid bodies, right? So the same definition you can write down here, that is mechanism is a combination of rigid bodies connected with each other to impart, you can simply write down, to impart definite or predetermined relative motions, right? And finally, the job of a mechanism is to transfer, very important. So the job of a mechanism is to transfer and modify motion, right? So how is it different from a machine? So remember this, a mechanism will not produce any useful work. So very important distinction I am going to make here. You have to remember this, because many a times people, they get confused between this machine and mechanism, right? So usually the subject name is kinematics of machines, right? So that's why people often get confused. They think that okay, we are going to discuss machine throughout the entire course, but basically when we limit ourselves to kinematics only, right, then we ignore this useful work part. Then we only talk of motion, because if we consider this useful work in the definition, right? Then we have to talk of forces, we have to talk of energy. But when we say that, okay, kinematics, then we are going to ignore this force, study of energy whatsoever, right? So in that case, we basically study the motion of a mechanism, right? So just remember that is mechanism, it is not going to produce any useful work, right? So this is how a mechanism is different from a machine. Now let us try to understand this through an example. So can anyone give me some example where you can differentiate between this machine and mechanism? So any example through which you are able to differentiate between a mechanism and a machine. Anybody?
Sir, a clock is a mechanism.
Okay, very good. Clock is a mechanism, right? Correct. So anything else? So let me give you the best example through which you will be able to differentiate between mechanism and machine very easily. So the best example of this is IC engine. So how? So let us see this. So let me draw a block diagram of an IC engine. So in an IC engine, let us focus on these components. Okay. So this is our cylinder, right? This is our piston. This is our connecting rod. And then finally you have the crank, right? And this fixed part, you can consider this cylinder and the other this thing. So you can consider them as fixed. So we generally call this as frame. So I will come to this. Usually they are not fixed, but since we know that is mechanism, machine, it is a combination of rigid bodies, right? Which are having relative motions with respect to each other. So they here what we consider frame. So let's say if two rigid bodies, they are not having any relative motion with respect to each other, so we can consider one body with respect to the another body at rest, right? So in that case we ignore that and we say like, okay, this can be considered as a model as a frame. So let us first try to understand this. So if you see the combination of these four elements, that is cylinder, piston, connecting rod and crank, you will find here that the motion, it is being transferred. So motion, if you talk, so motion is being transferred from the piston, right, to the connecting rod, and then to the crank, right? Now finally this from the crank, the motion is again sent to the crankshaft, and the crankshaft, the motion is again transferred to the flywheel. So here you can observe the crankshaft, it is rotating is crank pin bearings, right? So you can assume that these crank pin bearings and the flywheel, so all these parts like crank pin bearings, the flywheel, they are not having any relative motion with respect to each other, right? So in that case, you can model all these components, frame and the all other components which are exterior to these four components. You can model them as frame. So right now you observe that these four components, they are transferring motion to the crankshaft, right? So here they are not doing any kind of useful work. Here they are just, their purpose is just to transfer the motion, right? So the motion is being transferred from the piston to the crank, right? So here you can refer to this arrangement as a mechanism. You can call this as a mechanism. So basically this is a popular mechanism which is generally referred to as slider crank mechanism, right? So then what is a machine? So if this is a mechanism, then what is a machine? So it's very easy. So let us say that I I connected this part to a flywheel, right? And on the top of this cylinder, let's say I provided each and every arrangement. That is, I provided the fuel supply system, right? Then I provided the valves, right? Then I provided the ignition system, right? So I added all these components to this cylinder. Now what is going to happen? So when such a situation arises, then we know that the valve, right? The valves, the ignition system, the fuel supply system, they are going to cause the combustion of gases within this cylinder, right? So some power or energy will be produced inside the cylinder. Now this energy, if you connect this crankshaft to a flywheel, so this energy will be stored by this flywheel, right? So this energy will be stored by this flywheel, and then that energy is delivered to the wheels in order to propel the vehicle, right? So here if you see that we are going to derive some useful work if we connect this whole arrangement, this arrangement of piston, connecting rod and crank to a flywheel, right? So in that case you will refer to this whole system as a machine, right? Because now once you connected the flywheel, you are going to take some useful work from the machine, right? Or from the IC engine. So you can write down here that if you add fuel supply systems, ignition systems, flywheel, right? So if we add this, right, then it is a machine, right? So this is the primary distinction between a mechanism and a machine. So now I hope you all understand this. So till this point, like everything is clear to all of you. So any doubt till this point? Anyone?
No, sir.
So what if we
Sir,
don't have
sir.
the fuel system and ignition system, but the flywheel is there? Then will it be a machine?
So unless until you are getting this energy at this flywheel, right, then you will call it as a machine. But let's say like if you remove this, all this system, and if you are not getting any energy at the flywheel, right, so you can easily consider this flywheel as a frame, right? Because ultimately if you see this at this point, let's say at this point, you fix a crankshaft. On this crankshaft, this flywheel will be mounted, right? So now this crankshaft and the flywheel, they are not going to have any relative motion between them, right? So the crankshaft, it is mounted on flywheel, right? And the flywheel is turning along with the crankshaft. So you can model this entire crankshaft, let's say at this point, as a frame, right? But if you are getting some useful work, so that will be provided by this all this system, that is fuel supply system, valves, ignition system, right? Then in that case you have to consider it as a machine, because in that case you are getting some energy at the flywheel, right? And you are delivering. So basically I am talking that you connected the gearbox to this flywheel, then you connected the clutch plates, so all this arrangement you connected, right? And then you are going to get some useful work at the wheels, right, in order to propel the vehicle. Then in that case you will call this IC engine as a machine, right? So is it clear? Okay, so anything else beside this? Okay, so shall I go ahead?
Sir,
Yeah.
sir, here in this case, if we just remove the crankshaft, then we can say that the piston will move as the fuel is burning inside the cylinder, but the flywheel won't. So we can say that the no useful work is being produced.
Yeah, correct,
Correct?
correct. Right.
Okay. So
Right.
sir, this is the correct interpretation, right? Of
Yeah.
a
So
machine and
ultimately,
a
but
mechanism.
see, so my point is ultimately, so if you go to the definition, ultimately, if you can call this device as a mechanism. So first criteria is that whatever links or rigid bodies which are connected. So here you can see the cylinder, piston, then connecting rod, that crank. These all are considered as rigid bodies, right? So in addition to this criteria, the mechanism, it should not deliver any useful work. The job of a mechanism is only to transfer motion. In addition to this criteria, just add one more criteria, that these rigid bodies, they should have relative motion with respect to each other, right? So let's say if this piston, it is not moving relative to this cylinder, then we can model this entire, the combination of these two piston and cylinder as a single rigid body, correct? But since here we observe that piston will always move relative to the cylinder, so we model this as a separate rigid body, cylinder, and we model this piston as a separate rigid body. So in addition to this, you have to remember this criteria, that these links, they should have some relative motion with respect to each other. So it is not like that, okay, if two rigid bodies are there, right? So let's say one body is there and another body is this, right? So let's say if this is a sliding, this body is sliding with respect to this, right? The body 2 is sliding with respect to body 1. Then we can say, okay, this is a mechanism which is composed of two rigid bodies. But let us say if both are not sliding, both are at rest with respect to each other, or even both are sliding, even if this body 1 and 2 both are sliding, but there is no relative displacement. Let's say the relative displacement between this delta x, you can say it is 0. Then in that case, we are going to model these two rigid bodies 1 and 2 as a single rigid body, right? So beside this criteria, you have to remember this also, that this rigid bodies, they should have relative motion between them, right? So this delta x, or the relative displacement, you can say, it should not be equal to 0. It should have some value. Then only we can model these two as separate rigid bodies, that is 1 and 2, right? Otherwise we are going to model this as a single rigid body. So these two things you have to remember. Okay, so now let us go ahead. So let us go ahead and let us try to see the motivation part. Okay, so now I hope you understand like what is a mechanism. So the job of a mechanism is simply to transfer and modify the motion, right, in the way in which we desire, right? So let us try to understand the motivation. So why do we need to study this subject? What is the importance of this subject, right? So let me take you through some examples. So let's say one example you already saw, that is the IC engine, right? So to produce, the motivation is basically, so in simple words, you can simply understand the motivation to produce desired motion. So there are a number of industrial applications. Let's say if you talk of robots, automatic robots. So there also you need to coordinate the movement of the arms of different robots, right? So if you coordinate this arm movement, right, then only you are going to you will be able to control the motion of the final uh, which we call generally end effector. Then only you will be able to control this motion of these arms of the robot, right? So generally the motivation behind this subject is that wherever we need to produce some desired motion, then we are going to use a combination of basically rigid bodies, or we are going to use a combination of mechanisms. So the motivation is to produce desired motion for various applications, right? So one example you already saw. So let me take you through some other examples as well. So one fantastic example of a mechanism is locking plier. So let me show this thing through a video, that what is a locking plier.
Sir, the video is not visible to us.
Yeah, wait, I will share. Just give me a minute. I'm going to share. So is it visible to all of you now?
Yes, sir.
So this is, you can see here, like this person is showing a clamping plier, or we call this plier as a locking plier, right? So this is one example of mechanism. So see this, if you observe this, that this locking plier, it is composed of several rigid, let's say like bodies, or generally as we go further, we call this rigid body as links, right? So you can see here how this is moving. So this is one rigid body. Then this can be considered as another rigid body, this can be considered as another rigid body, and this handle, it can be considered as another rigid body. So now you can see here that, okay, these are connected through some joints. You can see here some bolts are there, right? Some bolts and nuts arrangement are there, right? And then this is being used to, let's say like clamp this particular wooden sheet, right? So this is one example of mechanism, right? So why do we need to study actually? So if you need to produce such kind of motions, right, then it is important to study this subject, right? Because in the let's say like in the third module, when I will be going to discuss synthesis, there you will understand. Now let me take you through another video which is also very good example of this thing. So is this video visible?
Yes, sir.
Okay, so this is can anyone tell what is this?
JCB?
Yeah, so this is a JCB, or generally we refer to this as excavator, right? But in common language, we call this as JCB. So here, if you observe, this is also a fantastic example of kinematic of this thing mechanism. So here, if you observe the motion of these arms, right? So this is, you can see here, this is one rigid body. Then this the arms of this JCB, you can consider this as another rigid body. Then this is another rigid body. Then this hydraulic actuator, it is consisting of piston and cylinder arrangement, right? So that means you can refer to this as two rigid bodies are there. So you can see here that these arms, which you can model as rigid bodies, all these arms, they are connected in a certain definite fashion. So they are not just connected randomly. They are connected in a certain definite fashion such that you can produce a definite rotation of this bucket, right? So a definite rotation through certain angle, it is produced at the bucket through this connection of arms, right? So this is another example of mechanism. So let me then again take you through one more example. So this is also very good example of mechanism. So can you see this video?
Yes, sir.
Yes, sir.
Basically, this is the video of a landing gear. So do you all know, I think, landing gear, where it is used? So can you tell me where we use landing gear mechanism?
Airplanes, that's the
Aeroplane.
Russian T-38.
So here, if you observe,
It's
so this is
mentioned.
also a fantastic example of landing gear. That means when your aeroplane, it is going to land, right? So the gear arrangement, it has to open in a certain specific fashion, right? So again, these arms, or you can say these rigid bodies, they are not just connected in a random manner. They are going to possess definite relative motions. That's why I always say that the relative motion will be predetermined, or it will be definite, right? Not just random or arbitrary. So now you can see here, so this is how the landing gear mechanism, like it works. So you can see here that it is composed of a number of rigid bodies. So this is one, this is another, this is another, and they are going to open like this. So all these are examples of this mechanism, and all these factors like their applications, all these things, right? The desire to produce, let's say, like definite motions wherever we require in industrial applications. So for understanding all this, the study of this kinematic of and structures of machine subject, it becomes important, right? So let me then end this here. So you can refer to this videos later on. So I will just write down like some examples so that you can refer to all these videos later on. So another is landing gear, then you have excavator, right? Then again this slider crank mechanism. So basically this is a part of IC engine. So fine, so these are other examples. Now can somebody give me alternative definition of a machine? So after discussing, let's say, the difference between a machine and a mechanism, so can somebody provide some alternative definition? Let's say like now, how can I define machine with respect to mechanism?
Sir, the combination of different mechanism which produces a
Right.
useful work is a
So
machine.
now you can very easily define that what is a machine. Alternative definition of a machine is simply, what is a machine? It is nothing, a combination of mechanisms, right? So that is going to produce some useful work. So that is going to, let's say, you can add this also, that is going to transfer motion as well as produce some useful work as well. So now this is just an alternative definition of a machine. Now let us come to, okay, one more very important thing I would like to mention here. So generally few people, they refer to this rigid body as resistant body also, right? So the rigid body and resistant body, they are almost the same. There is a like minor difference between both of them, but let us not confuse all of you, right? So for now you can just understand that rigid or resistant body, they are the same. So just tell me one thing. So in reality, is it possible that a body can be rigid body? Anyone? So in actual situations, is it possible that a body is entirely a rigid body?
No, sir.
No, right? So just remember this point, that a body, it cannot be like entirely a rigid body. There will always be some deformation. But what happens? Those deformations, they are very negligible if we talk of the relative motion of, let's say, like these rigid bodies. So compared to the relative motion of these rigid bodies, right? The deformation is very negligible. So that's why we ignore this. We generally say that, okay, this body is acting as a rigid body, that is, there is almost no deformation going within the body, right? So just remember this, and also remember this word, that in many books you will find that rigid body and resistant body, they use interchangeably. So there is a minor difference, but you can consider for now that, okay, both are same, the rigid or resistant body. Now let us go to the definition of, okay, so now let us talk about the definition of a link. So what is a link, right? So nothing, the link, the rigid bodies which I am talking about. So you can simply write down the resistant or rigid bodies, right? That constitute the mechanism, or they, or that build the mechanism, right? They are referred to as link, right? So these rigid bodies which are going to produce this entire like a structure of mechanism, right, or the entire combination of links, right, that is generally referred to as link. Now this link, it is also referred to as element, right? So always remember, like, because I'm giving you different notations, because in different books you will find out these things, right? So some in some books you will find they directly refer to the link as kinematic element, right? So now this is the definition of a link. So generally a link, it is of three types: binary and ternary and quaternary, right? So you can go ahead as, like, let's say like penta, then hexa, like that, right? So what is a binary link? So binary link, very important. So in a binary link, you will find that a single link is there, right? A single link is there, or let's say single link is there. Okay, fine. And there are two connections, very important. Always remember this thing. So these two connections, later on I will like talk about this, what is connection, what is kinematic pair, all those, right? So right now just remember this, that a binary link is that a single link will be there, and there will be two connections. That means you can connect other rigid bodies at these two points, right? Now ternary means you will now have simply three connections. Okay, so now one more very important thing. So can I call it as a single link?
No, sir.
Just
Yes.
think about it. Okay.
Yes.
So remember this here. Basically, this ternary link, it is a combination of, you can see here, three rigid bodies. One is this, one is this, one is this, right? So here it is a combination of three rigid bodies, right? That are having no relative motion. Very important, right? So here also you can refer to this entire thing, entire structure, as a single link only, right? The only thing is that this link is ternary link. That means this link, it is going to have three connections, right? Just wait for a moment, right? So I think now this is clear. So just remember that this is also a single link only, and you can refer to this as ternary link. But this single link is basically a combination of three rigid bodies. But why I am referring to them as a single link? Because these rigid bodies, they are not having any relative motion with respect to each other. But always remember, because of these connections, right? Because of the connection of the three rigid bodies, you got three connection points: one here, one here, one here. So that's why this link is referred to as ternary link. Now simply quaternary, if you talk of quaternary, so can anyone tell a quaternary link? It will be a combination of how many rigid bodies,
Four.
Four.
4.
right? So now this will be a combination of four rigid bodies, right? So now you will have, in this case, four connections, right? Now, after discussing this link part, let us come to this. What many times I said, like, connections. So what are these connections basically? So let us discuss about them, right? So generally these connections, they are referred to as kinematic pair, right? So what is a kinematic pair? So kinematic pair, it's nothing, a joint, or you can say a connection of two links, connection of two links having, or you can simply write down, connection of two links so moving relative to each other, right? So let us like see these examples, right? So now here, what are the types of kinematic pair? So we will understand this as we discuss further. So generally, the kinematic pair, it is divided into three types. Right? So first one is, you can classify this on the basis of nature of contact, right? Then the second is nature of constraints, right? And then the third is nature of relative motion. So generally, you can classify the kinematic pairs, right, into these three classes. So now under this, you will have further subcategories. So now let us see. So first is nature of contact. So based on this, you can classify a kinematic pair into two parts. So first is lower pair and second is higher pair. So what is a lower pair? Lower pair is if the two links have surface or area contact. Very important, right? So if the two links, they are having surface or area contact while moving relative to each other, then that pair is generally called as a lower pair. So can give me, let us again take this, the example of this is slider crank mechanism only, right? So this is cylinder, this is our piston, right? So now just tell me, can I say that this cylinder and this piston, they are forming a lower pair joint or lower kinematic pair,
Yes, sir.
Yes, sir.
right? So now this piston and cylinder, they are what? They are having a what surface or area contact, very easy. So here you are getting basically a lower pair. Now again, let me fix this connecting rod as well. Oh, I'm sorry. Let me fix this connecting rod. Now, again, we know that here we have one more joint. So what is this pair? Can anyone guess? So will this be a lower pair or a higher pair? So let me define higher pair as well. So it's very easy. So if you have a lower pair, you have surface or area contact. And if you have a higher pair, then two links have point or line contact. Now just tell me, is this connection, just imagine like how this connecting rod, it is connected to the, let's say, piston. So those you, I think like some of you have studied automobile engines, they have also registered for this course. So if you remember like how this connecting rod, this is connected to this piston. So we use I piston pin here, which we generally refer to as gudgeon pin as well, right? So there, if we talk of this gudgeon pin, so there we have piston pin, you can simply refer. So there, do we have this thing, surface contact or a point or line contact? Can anyone just guess? Will this be a lower pair or higher pair?
Point contact, Gajan pin.
Higher pair.
High? No, 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 no. See, what is a pin? If you talk of a pin, this is nothing. You have a cylindrical surface, right? In this cylindrical surface, it is fitted inside a cylindrical, let's say, hole, right? So this is your pin and this is your cylindrical, let's say, hole, right? So this is simply a pin arrangement, right? So here you definitely have surface contact because these two are cylinders, right? So when these two cylinders, they are connected with each other, so basically they are going to form a surface contact, right? So again, this pair is also a lower pair. Similarly, all other pairs here, all other pairs, right? So let me give you one more example to understand this further. So this pair, this connection, okay. So will it be a lower or higher pair? Just now think about this. At this connection, I just discussed that there is a crankshaft. So you can imagine a crankshaft which is perpendicular to the plane of this PowerPoint presentation at this point. Now this crankshaft, it is rotating inside bearings, journal bearings, right? So if you remember this simply simple IC engine or automobile engine course, whatever, right? So now here you simply have a crankshaft inside journal bearings. So now, do you have a point or line contact or a surface contact?
The
Just tell me.
point contact.
Again,
Surface contact.
surface contact, because a crankshaft is what? Cylindrical in shape, and this is rotating inside what? In bearings, which is also a cylindrical hole, that nothing, right? So now this is also a lower pair. So all these pairs here, if you observe, all these pairs are lower pairs. There is no higher pair within this slider crank mechanism. Now let us discuss about higher pair. So can anyone just give me some example? Where can we encounter such situations? Let's talk of automobile only. So in automobile, can anyone give me some idea, like which two components they can be referred to as, okay, they are forming a higher pair. So think
The
about
shaft and the
shaft and
wheel.
shaft and wheel.
Wheels. Yes.
Okay. So one is this. So let us go one by one. So this is the IC engine part. And after the engine, you have clutch plates, right? So let's say, like, if you talk of clutch plates and flywheel. So if you connect this clutch plate with flywheel, so what is this? This is again surface contact. Again, it will be a lower pair. Now let us move further. After the clutch plate, you have gearboxes. So can you say, like, in gearbox there is like some point or line contact somewhere? So this is obvious. So let's say if two gears, they are meshing with each other, correct? So two gears are there. So two gear wheels are there, let's say.
Yeah,
Okay,
sir.
so
Point contact.
right. So I'm sorry, I'm not very good in drawing this gears, right? So I will just tell you directly. So when two gears, gear teeth, right, come in contact, then again, first is this is also very important to observe, that a gear is generally used to transfer motion, right? It will transfer one rotary motion, let's say, like, from one shaft to another shaft, right? So first is this, that they are going to these two gears, if we consider these two gears as two links, they are going to have relative motion. And another is they are having a line contact, very easy, right? So in this case, we will refer that, okay, this is going to constitute a higher pair,
Sir,
because
but how a line contact? Because see, they still have a bit of the surface in
no, no,
connection,
no,
right?
no. See, there is two teeth are meshing, right? So these two teeth are meshing. So you all always know. So they are generally, they have this involute profile, right? So first, what happens actually, if you talk of, let's say, spur gear, right? So for a spur gear, these two teeth, they are going to mesh directly. So this is very easy to assume. They don't have any surface contact, right? So these two teeth, they have like these kind of involute profile, right? So one is coming to mesh like this, another comes to mesh like this. So generally they mesh along this line, right? So you can imagine a line here which is perpendicular to this plane of PowerPoint presentation. So they mesh, these two teeth, they mesh along a line. They don't have any surface or this kind of contact, right? So just if you observe the motion of two gears very carefully, so they have a line contact. And when you talk of helical gears, so this is the case with the spur gear. And when you talk of helical gears, then generally the helical gears, they start engaging. Let me draw this slightly like this. So the helical gears, they start engaging along a point. Then slowly as the gear turns, they start coming in, let's say, like this point, it will start tracing along this entire profile of this involute teeth, right? So this is slightly, like, right now maybe complex for you to understand. This involute part I will discuss later, but right now just keep in mind that the gear teeth, they don't have any surface contact, right? They always mesh along a line or a point, right? So just remember this, there is no surface contact between two gear teeth. Okay, so let me give you one more example of a higher
Sir,
pair.
sir.
Yeah, yeah, yeah.
Sir, if we consider a motion of two bodies, so where one of the body is performing a linear motion, uh,
Right,
and the uh, another one is performing the rotatory motion, sir. So
right.
the point where
So,
they both are
right.
joining, sir,
So,
that would be a point connection, right? Point.
correct, correct, correct. So now this is one example. Another one you can simply take, let's say like the wheels. So this is your road, right? And now you have wheels, right? So now these wheels, they are moving over this road. So this road is stationary, but the wheels are moving, right? So now these two links, if you model these two as two links, so this is, let's say like the fixed link one, this is link two. So these are having relative motion, and at the same time, they are having a point contact here, right? So you can refer to this as higher pair, right? So wheels on a road. Right? So for today, I think like this much is sufficient because today is your first day. So let us not go into further details. So I will restrict myself till this point. And later on we will discuss that how can we like subclassify this kinematic pair on the basis of, let's say, like constraint and on the basis of relative motion. Right. So this is just for now. This is enough. That is lower pair and higher pair. So any doubt till this point? So this gear part, I will make more clear when I will discuss this gear chapter, right? So some people, let's say, like ask, like, how is this going to have a line or this contact? So I will discuss this, that they have an involute profile, and this involute teeth, when they come in contact, they contact along a line, right? Okay. So anything, any doubt till this point? Yeah, the PPT definitely I will share. Don't worry. PPT and everything will be shared to all of you. So anything else which you want to ask? So shall I end the meeting? So if
Yes,
you
sir, that
have
should be fine.
Yes, sir.
if you have any further query, you can email me, you can write to me. Okay, I will reply. So I will share this PPT and all these things. I will make a folder, YouTube link for videos, recordings, everything. Okay, so don't worry.
So what about attendance?
Attendance I will take from this Zoom reports, right? So whoever has logged in, so the Zoom report is available on this thing, the web browser of Zoom. So from there I will take and like I will mark your attendance. But make sure that you have attended your lecture for sufficient amount of time. Let's say it should not be like that you logged in and then you left the meeting after 30 minutes, right? So it should not be like that. So just remember this. So it should be at least like 1 hour, 15 minutes or something, unless until there is no connectivity or internet problem, right? Okay, then thank you. Thank you all of you.